Alright, so this is a continuation of graphing tangent cotangent. Let's do one more example of graphing cotangent to make sure we remember how to graph it. Remember, this is going to be our inflection point. Think of kind of like the concept of the amplitude for sine and cosine. The first thing you want to do when you're graphing the graph of cotangent is to find your vertical asymptotes. So remember, we're putting everything that's happening to the right of cotangent in the inequality from 0 to pi. And then we're going to solve for x. How do I solve for x here? What am I going to subtract on all sides of this inequality? Pi over 4. Good. God bless you. So we're subtracting pi over 4. And my leftmost asymptote is going to be negative pi over 4. And my rightmost asymptote, if it helps you, remember that the common denominator for pi 4 and pi over 4 is going to be pi over 4. So 4 pi over 4 minus pi over 4 is going to give me 3 pi over 4. So I just found my vertical asymptotes to the given graph. The second thing I want to do is identify the midpoint of those vertical asymptotes, because remember that midpoint is going to represent the one and only x-intercept in that one cycle for cotangent. So I'm going to take my left asymptote, I'm going to take my right asymptote, I'm going to add them, I'm going to divide by 2. When I add them, I'm going to get 2 pi over 4, which is pi over 2. And divide that in half, you get pi over 4. So this is your midpoint, or your x-intercept. The next thing you want to do is find your 3/4 and your 1/4 point. To find your first quarter point, you're going to take your left asymptote, which we said was negative pi over 4. You're going to add your midpoint. You're going to divide that in half. Negative pi over 4 plus pi over 4 is 0. 0 divided by 2 is 0. To find your third quarter point, you're going to take your right asymptote, 3 pi over 4. You're going to add your midpoint, which is pi over 4. Don't forget to divide that by 2. 3 pi plus pi is going to be 4 pi over 4, or just pi over 2. So I found my vertical asymptotes, which were negative pi over 4, 3 pi over 4. I found my midpoint. I found my first quarter point and my third quarter point. That's enough to graph one cycle of cotangent. Okay, so this is what our coordinate plane looks like. Remember, our two vertical asymptotes are happening at negative pi over 4, at 3 pi over 4. We established that the midpoint was at pi over 4. Our point of inflection, remember that the cotangent curve begins at an increasing point and then ends at a decreasing point. So the cotangent curve for one cycle looks like this. Notice that the smallest unit here is in terms of pi over 4, so if I wanted to continue to add another cycle, I'm going to keep adding pi over 4 to the right. So this is going to be 4 pi over 4, or pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2, and 7 pi over 4. So there you're going to have another vertical asymptote. The midpoint is going to be an x-intercept. Then remember, you have your inflection points here and another cotangent curve. Okay, so now we're going to talk about the graph of cosecant. When we're talking about the graph of cosecant, what we're evaluating is y equals cosecant of x. But that equation is going to be equivalent to y equals 1 over the sine of x. Remember that the reciprocals were equal. Remember that, guys? It was the same concept? Okay. So let's explore the unit circle and let's see what happens with 1 over the sine of x. So remember, we're evaluating the reciprocal of sine. So wherever sine is some value, so a half, square root of 2 over 2, square root of 3 over 2, 1, 0, we're going to put that for cosecant. So remember, we're evaluating what y equals 1 over the sine of that value. So when we create our table of values, what we're going to do is, let's take those angles, the quadrantal angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And remember, I'm going to take the reciprocal of it for cosecant. So at 0, What's the reciprocal of 0? I'm going to get undefined, right? At pi over 2, what do I get? Right here. The reciprocal of 1. 1. At pi, what's the reciprocal of 0? It's going to be undefined again. At 3 pi over 2, which is down here, we're going to get negative 1. Good. And at 2 pi, we're back here. We're going to get undefined. So notice that the pattern is 0, undefined, 1, undefined, negative 1, undefined. So when I'm evaluating, let's take a look at it graphed. The graph of cosecant at intervals of pi. I'm going to have these points at which we're undefined at. And remember, we're flipping over small fractions. So whenever I flip over small fractions, the value becomes very large. So what's the reciprocal of an eighth? 8. So that value is going to shoot up for the reciprocal, right? Whenever I have a half, we're going to shoot up to 2. So the closer and closer we start getting to this asymptote here, the larger the value for cosecant. Same thing in the opposite direction. So you're never going to have any of these small values between negative 1 and 1. So some characteristics to keep in mind for this graph are as follows. The period is still 2 pi. The domain is the set of all real numbers except integral multiples of pi. The range is all real numbers, y, such that y is less than or equal to negative 1, or y is greater than or equal to negative 1. Why? Because we took all those small fractions, we flipped them over, and we made the outputs very large for cosecant. We also have vertical asymptotes at integral multiples of pi, and it is an odd function. Remember, odd function means it has origin symmetry, and I see that happening here. I have origin symmetry in this direction. So notice that when we're going to graph, what we're going to do is we're going to graph the graph of sine, and then we're going to create these asymptotes wherever sine touches the x-axis, and then we're going to create these parabolas wherever sine has the maximum or minimum value. So let's take a look at an example. Okay, so example number 6 says graph y equals cosecant 2x. And make a little note that the first thing you want to do is graph y equals sine 2x, then graph its reciprocal function. So the first thing I'm going to do is I'm going to graph as if I'm graphing y equals 2 sine x. Remember when we graph sine, the first thing we identify is our amplitude. What is the amplitude here? 1. Good. The second thing we identify is the period. What's the formula for period? 2 pi over b. Good. So here I'm putting 2 pi over 2, and I get pi. The third thing I want to do is identify my quarter periods. So I'm going to take the period, divide it into 4 parts. The next thing I want to do is identify my 5 key points. Remember, if we have no phase shift, we start with our first point at x equaling 0. Your second point, you add your quarter period, and then you keep adding your quarter period to every additional point. So pi over 4 plus pi over 4 is pi over 2. Your next point is going to be 3 pi over 4. And your next point is going to be 4 pi over 4, or pi. Remember, if there's no phase shift, that your period is going to be the same as your final point. So now we're going to graph sine. Alright, so let's graph sine. Remember, sine always starts at the origin, goes to its maximum, intercept, minimum, and intercept. And I'm not going to connect the points. I'm going to create kind of like a vague impression of it, because this isn't really the graph of cosecant. Wherever this graph touches the x-axis, that's where I'm going to create vertical asymptotes. And wherever this graph has a maximum or min height, that's where the parabolic effects happen for the reciprocal. If we wanted to add another period, we could go ahead and do that. Let's do that to the right. Keep adding pi over 4. So that's 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. Remember, maximum, intercept, minimum intercept. So here's our sine curve continued. Again, wherever it touches the x-axis, you have these vertical asymptote. Wherever it has maximum and minimum points, you have these parabolas. The graph of secant is similar to what we just did. It's, remember, the reciprocal of cosine, and remember cosine of x, secant is equal to 1 over the cosine of x. So wherever cosine of x is 0, secant is going to be undefined. So it's also going to have those vertical asymptotes. And wherever secant, cosine is a very small value, secant is going to be very large, and that's why we have these parabolas here. The period is still 2 pi. This time we have the domain as all real numbers except odd multiples of pi over 2. We're still excluding values between -1 and 1. And we still have vertical asymptotes. This time we have an even function. Reason being is that we have y-axis symmetry happening right here versus origin symmetry in the graph of cosecant. So when I graph this, what I'm going to do is I'm going to graph the graph of cosine, and then wherever cosine touches the x-axis, you're going to have the vertical asymptotes, and wherever cosine has these maximum and minimum values, you're going to have these parabolas. So let's take a look at an example. So in example number 7, what we're going to do is we're going to graph y equals 2 secant 2 pi x. Again, the first thing you want to do is graph y equals 2 cosine 2 pi x, then graph its reciprocal. So remember, when you're graphing y equals 2 cosine 2 pi x, the first thing you want to do is you want to identify the amplitude, which is, then you want to identify the period, which, good, 2 pi over b. Here it's 2 pi over 2 pi, which equals 1. Then you want to identify your quarter period. Take your period, divide it in a quarter, and you get 1 over 4. This is going to make it very easy to identify the 5 key points. Remember, if there's no phase shift, your first point is going to be with x equaling 0. Your second point is going to be that quarter period, and then just keep adding a quarter until you get your 5 key points. So now that we have our 5 key points, remember the 5th point is going to be equal to the period so long as there was no phase shift. And now we can go ahead and graph the graph of cosine. Alright, so here's the coordinate plane for what we're about to graph. Remember, we're graphing cosine to start, and cosine always starts at its displacement, intercept, minimum, intercept, maximum. I'm going to add a cycle here. And I'm going to connect these points very faintly because we're not interested in the graph of cosine, we're interested in the graph of secant. And wherever cosine touches the x-axis, I'm going to create vertical asymptotes. And wherever the graph of cosine has maximum values, we're going to create the parabolas. So we've talked about all 6 curves for our trig functions. Remember, here's the graph of sine. The domain's all real numbers. Range is -1 to 1. Its period is 2 pi. Here's cosine. Domain is the same. Range is the same. And period is the same, except it looks like a shifted sine curve. Here's tangent. Domain is restricted. Range is all real numbers. Its period is pi. Cotangent, the period is also pi, domain is also restricted, the range is set of all real numbers. The domain and range for cosine, cosecant, and secant are, both of those are restricted. The period is 2 pi.